In this video, the second part of 14b, we're going to look at measures of centre and spread for binomial distribution. So our measures of centre from our work in earlier years are the mean, the median and the mode. So the mean is your average, add them all up and divide by 10. The median is the middle one when you put them in order, and the mode is the one that occurs most often. The measures of spread you will have come across in previous years are the range, possibly quartiles, and possibly interquartile range as well. Hopefully you will have seen one of these box plots before, and that will allow us to talk about quartiles and interquartile range. But we will also introduce you to two more measures of spread. The first is not really a measure of spread, but it helps us to get one: the variance and the standard deviation. So let's make a start with measures of centre. So our first measure of centre is the mean, which has this symbol, which is a U with a little stick on the side. It's the Greek letter mu. You pronounce it mu. The mean for probability is also called the expected value, and it has the symbol E of X. And it is basically how many successes you would expect to get on average in the long run. So our mean is in fact a theoretical value, and because it's theoretical, it may not be an actual X value itself. So for example, an NBA player has a 3-point percentage of 34.4%. That means when they take a 3-point shot, they have a 0.344 chance of success and a 0.654 chance of failure. So what you would expect in the long run is that however many points a player attempts, however many shots a player attempts, that they would be making around about 34% of them. So let's have a look at what that means. So here I've got a probability distribution with 10 attempted shots. Our probability of success is 0.344, and this is our formula for our probability function. So let me just zoom in on this and I'll write it probably for you. So we should actually have here at the start probability that X is equal to X. So this is its proper function notation, is equal to, and this is our NCR, this is our probability of success, and this is our probability of failure. And so this is the value that you will have. It will generate the probabilities for you for 0 to 10. And for all other X values, the probability is equal to 0. So this is what our graph looks like here. So what we're looking at is if we've had 10 shots, we would expect 34% of that 10 times 0.344, we would expect 3.4 of those shots to go in. So on our probability distribution function over here, our expected value is at this point on our x-axis. And when we ask Wolfram Alpha to calculate the mean, it comes up with exactly the same answer as what we had. And that is exactly how you calculate the mean for a binomial distribution. You take your number of trials and you multiply it by the probability of success. But let's have a look a little bit closer at how we would place the mean on the graph of a probability distribution function for binomial just by eye. So the mean can be thought of as the balance point of a distribution, which would be the X value where you would put, if this line here was a seesaw, where would you put the fulcrum? Where would you put the little bit that would balance up this distribution? would you put the little balance point here? Or would you move that balance point here or here? Where would you put that balance point so that the whole thing would balance just on that particular point? Well, what you can do is you can think about the distance that those points are away from each other and try and find a point somewhere on the x-axis so that the sum of the distances below that particular point. So from this point here to this point here, there's a distance of 2, and this is a distance of 1, 1 and 1. So total distance of all of these points from this point here is 5. On the other side, you've got a distance of 2 and a distance of 3. Total distance on this side is also 5. So this is the balancing point for our distribution. It is also the mean of all of those values. And if we calculated it the old-fashioned way, by adding all of these values together and dividing by how many there are, guess what we get? We get the same answer as our balancing point. So let's have a play with that. So have a go with these graphs here. You can see the number of trials at the top here and the probability of success, and see if you can visually pick out roughly where it will be, and then I'll let you know what the answers are. So take a second to see if you can visually guess where it will go. How did you go? So to find the mean, you can simply multiply the number of trials by the probability of success, and that works in all cases for binomial distribution. You can also look for the balancing point for the graph. So that's our first measure of centre, the mean. Let's look at the median. So the median is the middle value that we get in our data when the data is put in order. And it doesn't matter whether it's from highest to lowest or lowest to highest, you're just looking for it to be in order. So how does that work with a probability distribution? So let's have a think about a situation where we've got a fair coin, it's flipped 3 times. If x is the number of tails, the observed probability distribution of x is given by this table here. So where are our numbers to find the middle of here, to put them into order? We don't actually have any numbers. What we've got is some probabilities. So what we're going to do is we're going to make an assumption here so that we can understand what's going on. We're going to assume that we're going to do n equals 1,000 trials. And we're going to assume that we get the exact proportions that our probabilities predict. So there'll be 125 zeros, there's the first 10 of them, 375 ones, there's the first 5 of them, 375 twos, and 125 threes. And so we have, if we continued these on to have the number that they are supposed to have, 1,000 of them all up, we have the numbers in order. And so what we're looking for is half of that 1,000, and half of our 1,000 is 500. So if we count in 500 places, 1, 2, 3, 4, 5, etc., 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 we'll end up here in between the two. At exactly the point where the ones finish and the twos begin. And so what we do when we find the median and it's in between those two is that we find the average of those two numbers. We add them together, divide by 2, and so we get 1.5. This indicates that when we did this experiment, flipping 3 times, a fair coin 3 times, half the time we'd expect to get less than 1.5 tails, and the other half the time we would be expecting to get more than 1.5 tails. So we'd be expecting to get either a 2 or a 3 as our result. So our median for this distribution is 1.5. Another way that we could do it is we could start from this end and think about adding up the probabilities as we go. So we get to here and we've collected 125. When we continue along here up to here, we've got 0.5 as a total of our probability, our cumulative probability. And so what we can use to solve this problem of finding the median is we can use this idea of cumulative probability. And on your CAS calculator, you've got a binomial cumulative distribution. So we're going to use the basketball example here with 10 trials and a probability of success of 0.344. And this is our probability table for all of our different x values. So to use a cumulative distribution, you need to make sure that you select this option on your CAS. And when you put in the information, you'll have a lower bound and an upper bound. That says from which x value do you want to start adding the probabilities to, and where do you want to finish. So you can see in this example I've got lower bound as 0 and upper bound as 1. What that does is that it adds these two probabilities together. Those two probabilities get added together. And so when you put this into your CAS calculator, this is the one that you get, where we've got at the top from 0 to 1. And those two probabilities, when you add them together, add up to this. And then what I did was I just copied and pasted and changed the bounds that I was working in. So this next example here goes from a lower bound of 0 to an upper bound of 2. And so it adds together all of these probabilities. And that's what that adds up to. And so you can see I've done it a third time from 0 to 3, which is adding up all of these probabilities. And this time it adds up to more than 0.35. So our median must be one of the numbers that is in. So all of the 3's, when you finish counting all of the 3's to here, that's a total of 0.53. So 0.5 must be within one of those 3's somewhere. So here, if you like, our median is equal to 3. The other way that you can do it is you can use a different distribution. So to use this one, you use menu 55B. The other one that you can use is the inverse binomial, and there's two inverse binomials, so make sure you get the right one. So this is just inverse binomial, not n. We'll talk about this one in a minute. And when you select this, there's two different ways that you can put your data in. So you can see that I have put in a cumulative probability of 0.5. So I want the probability to add up in total from my lowest value to my highest value of x to be 0.5. Number of trials is 10. And you can see the difference between the two screens I've got here is one doesn't have the matrix form ticked and one does. What the unticking does is that it gives you this answer here, which just says the median is 3. If you ask for it in matrix form, if you take this ticked form here, it gives it to you in this form. And what it's telling you here is that this is our first x value, and this is the cumulative probability for that. So can you see that that matches with that they are the same value there. And then it also tells you for the value of 3 what that cumulative probability was. And can you see that that is exactly the same as that? So the matrix one gives you a little bit more information, and if you use the matrix one, you'll need to figure out what the median value is yourself. So the final measure of centre is the mode, and so the mode is the most frequently occurring outcome. It's also the one with the largest probability. So if we use our basketball example with 10 trials and a probability of success of 0.344, we can find the mode from the table of probabilities and from the plot really quite simply. From the table of probabilities, we're looking for the largest probability. So 0.01, 0.07, 0.18, so they're getting bigger. 0.25, 0.23, 0.14. So the biggest one is actually this one here. On the graph, remember the vertical axis shows you the probability, and so you're looking for the highest value along this axis, which is this one here, but the actual answer for the mode is this particular x value. Okay, so your mode is an x value, and the x value for that is 3, and therefore the mode is 3. The mode is not the probability itself, the mode is the x value with the highest probability. And finally, is there a way to work out the mode using just the n value and the p value, like we've been able to work out the mean and the median with our CAS calculator? Well, there is, and it's a little bit of a tricky thing. This isn't actually in the course per se, but you can actually use a formula. And this is the formula here. And these yellow little L's, backwards and forwards L's, represent what we call a floor function, which means basically work out what's inside and then round the answer down at the end to the nearest whole number. So we've got n and p, so our n is 10, so 10 plus 1 is 11, multiply that by your probability, you'll get 3.78, and then the floor function says round that down to the nearest whole number, the answer is 3. So you can use this function to find the mode with simply just n and p.